Good morning and welcome back to our second day of conference talks. Before we start with Simon on Apt Transparency, just a quick note. It is expected to rain around noon, so please don't leave any stuff lying around outside, just in case you're inside and it starts raining.
It's raining now.
Oh, it's raining now. Okay. So don't leave any stuff lying outside. Thank you, and the stage is yours.
Thank you. Thank you for the rain helped me get you in. Yeah. So welcome. I will talk about Apt Transparency. I will explain what it is. So basically the problem I'm trying to solve is that when you do an apt-get update and install on some package, the question is which binary do you get? Is it what Debian intended to publish? Did you get the same version that everyone else did? So right now, Debian, the trust chain chases back to PGP keys in dash etc. And they are authorized to sign these release files that apt-get downloads. So what PGP keys are we trusting? So you can ask question about any private key, and the more important it is, the more important to have some assurance about its properties. I think summarizing, there are many questions. Some really old Debian distributions uses insecure keys, and while some people may want to just ignore old stuff, I think it's useful for reproducible and bootstrappable builds to be able to securely fetch earlier versions of Debian. Also, you can ask the same about, it's not Debian, but it's related. Ubuntu 24.04 just released with signed using a 2018 key. It's fairly old. Debian has better practice to rotate keys, but the same questions about where it came from, who's holding it, did it has to be surrendered to legal authorities, and so on. There are no answers on that. And then you have all these third-party apt repositories out there that a lot of people use for, I don't know, Docker, NVIDIA stuff and no one knows how those private keys are handled. I even found Triskel had some DSA El Gamal key in active use. It's deprecated 15 years ago. So I think summarizing, it's fair to assume there is some risk that keys are compromised. And you may have read kernel.org was compromised 12, 13 years ago. It's big news recently. So what can you do if you have the private key? Basically, you get some signing access to it, maybe just logging into the appropriate machine, being able to sign. You don't have to actually have the private key. And you prepare some modified release file pointing ultimately to your modified packages. And you get that signed, and you do a man-in-the-middle attack on your target, which is fairly simple since the defaults are still using HTTP, not HTTPS, and wait for the system to upgrade or install. So the WebPKI community had this problem many years ago and introduced the certificate transparency to solve it. They had CAs issuing fraudulent certificates. And it creates an audit trail for all signed certificates from a CA. And on misuse, this is quite useful material to have to bring up a conversation with that party to have some fact-based discussions. And my question is, why don't we have this for apt? So let's go into some details. Apt calls out to GnuPG's GPG-v to verify the signatures. So my idea was that I don't want to I like to go into controversial topics, but you can't go into all of them at the same time. So I'm trying to stay out of the GnuPG versus anything else. I think Holger is doing a nice talk about that later today, which I recommend. But it calls GPGV, and my idea was to not replace it, but just augment it with another tool that can reject signatures, not accept anything else, but just in addition to GnuPG, also be able to reject something that's not seen by everyone else. So I wrote a small apt verify script. This is the entire script. It basically runs a couple of tools from a directory, and by default there is a symlink to GnuPG in there, or GPGV, and you can add more tools to it. And it's fairly simple. And my first idea was to just, okay, I downloaded release files on some system. I know this is a good, genuine Debian distributed release file. I hash it and put that in a file somewhere. And if I can download the same I call it a canary file on my system, I can at least verify that I will be using the same release file that I used on the other system. So it's a bit of an improvement to not accept just anything, but accept something that I've seen elsewhere. That's the basic, simple idea. And the garbage on the screen is just for entertainment. But that's the essential part of the implementation. So where does that URL go? Is it really an improvement? Right now this is just going to simple GitLab repo where I put all the release files that I can download. And in this Git repo I commit all the release files. So it leaves publicly available, auditable, trusted Git repo of all the files that I've seen for later analysis. And this eventually took up some size, and I discovered Git LFS. It's a different talk, but I had to set up some storage to store everything. And when I had this, introducing this canary file was simple. But trusting GitLab, HTTPS, that's not really feel like an improvement. You can replicate this idea to GitHub, something else, but still the fundamental idea that this is maybe not the best way to go. It's just a simple way to get started to do something. Started to look into, there are various blockchain ideas out there which would be a more standard or more interesting technology to look at. There are Sigstore and Sigsum are two public transparency logs that are general purpose. Certificate transparency just for certs. So we need something general purpose, and I didn't want to design my own transparency log. That's a whole other thing. And both of these are implemented in Go, so I had to learn some Go packaging. I eventually managed to package Sigsum and Recore from Sigstore. Let's go into Sigstore. They have two different functionalities. They have the Reco, where you can append a PGP signature to a log, and then it will be later possible to assert that this is a PGP signature that the log has seen and get a witness from that. Reco is a bit simple in that anyone can add to this log. It's one of the fundamental ideas with it, which means the attacker can also add their malicious PGP signature. So, but at least it makes it creates a public audit trail of things. Sigstore also has a co-sign tool, which is basically signing something and adding some meta information that allows you to verify that it was added to a transparency log later on. One caveat with this is that the security team is not covering Go packages, so depending on this for production will require some more discussion or rewriting it in some other language, which is feasible. I think this technology is you can implement it fairly in a fairly short script in Python or something. And also about packaging, this Record tool has about 390 build dependencies, and that's kind of the Go ecosystem. And I haven't yet finished the cosign tool. It's more than 390 packages that you need to have to build it. Sigsum is another initiative. It's also a transparency log, but they take a minimal approach, which I started on Sigstore and kind of worked for a month getting things to work in Debian. And then I kind of, okay, this is really taking time. I need some alternative. So I looked at Sigsum, and in 1 hour I had this built and backported. I had to wait for the new queue, but then backporting the bullseye was, in 1 day, that was complete. So not all Go code creates a dependency hell. You can write Go code that's not have a large dependency tree. Unfortunately, they don't have a public log running. So one idea is to combine this with reproducible builds. This is an idea that all the packages you install and upgrade, it would be nice if they would have been reproducible builds. So not only do I want to prove that someone else saw this release file, I would like to be able to prove that someone else tried to build the package I'm installing and get some proof of that. Eventually it should be successfully reproduced, but I could live with just having someone trying to build this, publishing a diffoscope output of the differences. I think that would be quite an improvement on the current, where you just download and install whatever happens to be in the Debian archive. So that's work in progress, and ideas welcome. So all of these are just hacks, out-of-band hacks on top of apt. There is some discussion on extending apt to support this natively. Basically, you're augmenting the GnuPG signature with something else. Filippo calls this a spicy signature. I think it's a good mental model to think of it as it's a cryptographic signature, but with some more information that allows the consumer or verifier to make sure that the signature has been appended to some transparency log. And this is even an offline operation. You don't need to talk to the log to verify this. So it's quite nice properties. And this is also work in progress. So if someone is working on apt or want to talk about it, please, that would be good. So these are some ideas how it could look in the release files, just adding the Sigstore information or adding the Sigsum proof. So this is mostly a general introduction to some of these concepts and some of what I'm working on. I hope to get some discussion out of it, but some reminders about state of things that, okay, this may be an improvement, but you're still trusting hardware manufactured by someone to run your software, and you're still trusting a lot of software that you have. It's fairly infeasible to audit all of Debian code, so you have to trust it to some extent. Reproducible build gives you a sense that the state is better by at least, the binaries have some correspondence to the source code. And with Apt Transparency, you have some connection that you are using the same binary that everyone else, hopefully, is using. But I think it's somehow we see reproducible builds or transparency logging as a solution to all software ecosystem issues, but the fundamental problem has always been there in trusting your hardware and trusting the software, and that doesn't go away. So with that said, yes.
Thanks a lot, Simon. Are there any questions?
Yep.
Four. Why you choose RSA, not elliptical curve?
I think this is orthogonal to signing algorithm.
Yeah, because you choose a 1024 bits key, right?
What uses?
For RSA, your 1024.
Yeah, I'm not using DSA. There's no.
Okay. Yeah, because Chinese, they're almost there to break.
Yeah. I mean, DSA is really old and insecure, but it's still. I mean, it was part of the Triskel trust chain.
Okay.
So I wouldn't use that at all.
I saw in your script also you're using SHA-256. Why are you not using a CMAC or HMAC? Because to authenticate also, because you only ensure integrity.
So question to use a symmetric keyed hashed or. Yeah, it adds a key management problem, but definitely you could do it.
And last question, why Go not Rust? Because people are telling that Rust now is suggested for security because like a lot of problems in memory.
Yeah, I'm just waiting for someone to write a Rust implementation of Sigstore and Sigsum. I think that's basically the reason I settled for shell script and wget and the simple canary approach, because I wanted to get something to work, and kind of waiting for people to write software is takes some time. And there are these questions about the Go and Rust ecosystem support.
Okay.
But to be honest, I don't know if anyone is working on that. I know there are people working on Python implementation of both Sigstore and Sigsum, which may be simpler.
Nice project. Congratulations. Really nice idea.
Okay, thank you.
Do I understand correctly that one of the problems you're facing is that you'd like to add another signature to the release file?
It's one way to solve this if people are interested in doing that.
Then let me point out that on the Debian Wiki, the Apt team, and Julian Andrestode in particular, is proposing to change the mechanism we use for embedding signatures into release files. Mm-hmm. Are you aware of that?
Yes, I looked at it.
And that would easily allow embedding further signatures after the fact, and it allows the release file being signed by more than one algorithm and like that.
Yes, I'm aware of that, and it's a nice way to do something simpler. I think it's a good work, but it's a bit orthogonal to transparency logging. The signing could be done by GPG, it could be used by X59, it could be used by minisign or the proposal. But the transparency logging needs some more information.
Are there any more questions? There's one.
Hi, I have a question regarding the threat model. Mm-hmm. So the threat model, if I understand it correctly, is that you assume that an attacker might be able to gain access to the private key material that is used to sign the archive.
Right.
So if we assume that an attacker is powerful enough to get to the archive signature key material, which is hosted on the same host, is it not possible that he can corrupt anything else there as well? So how does that, I mean, adding a transparency lock somehow gives you an auditable trail. I get that, but what can you actually verify that helps you against this attack? If someone, so your example was someone mounts a man-in-the-middle attack afterwards to give you some falsely signed release files, but he might just as well go ahead and sign the release file on the original archive, and any checker will find the corrupted release file at the source.
Yeah, I mean, there are limitations to what this gives you, and this there is no protection against that, but it gives an auditable trace of it. It's the similar that certificate transparency gives you, that you at least make this public, and that's the only thing that this gives you, really. But making it public forces attackers to maybe modify the way of working, because they like to work without making things public.
You mean you told the problem is that the private mini-debs, right?
Yeah. So
The
the thing with the certificate transparency is that it guards against a slightly different scenario, namely that certificate authorities basically can sign everything they want. So if you have a transparency lock, then you can check afterwards that a rogue CA has not signed, say, a Google certificate, even though they had no business signing such a thing.
Right.
But that doesn't necessarily mean, for us, we are just signing our archives files, and this is a legitimate use case. And it's not clear to me that you can distinguish this in a transparency lock, whether this was just one of the many updates that happens, like 4 times a day, or if it was a rogue one. So I like the idea, but I think there's still a lot of wiggle room where you need to be very clear what's the threat model, what can the threat actor do, and how do you guard against that.
Yeah, I think that has to be well documented and well understood. And you're right that this doesn't prevent anything from happening. The idea is to make sure it's publicly auditable and possible to go back and see what happened.
One final question.
I had a very similar thought as you in the beginning of the talk, so I was a bit confused about what this was about in the first place. And my thought was in the beginning, but I guess that's wrong, so hence my question, is this about, but this is not about, or is it about that Apt, when you give it keys, it can trust, and it does not associate the repositories have configured with the keys, at least not by default, at least not yet. There are facilities, but and you can use it right now, but it doesn't do so by default. So theoretically, if you have random repositories configured, then the owner of one repository could take over another one with the keys that they have.
Yeah, that's a very good. This doesn't really solve that problem directly. It can provide some improvement on this, at least that with the additional configuration, you can make sure that you authorize certain keys for certain release files. But it's a good problem that we have. But this is really orthogonal to this.
Okay, thanks again, Simon.
Thank you.